This video is part 3 of the probability distribution and expected value for discrete random variables. So we're going to pick up with this slide, example 3, lottery. In the New York State Numbers Lottery, you pay $1 and pick a number from 000 to 999. If your number comes up, you win $500, which is a profit of $499. If you lose $1. What is your expected value? The probability distribution for that is shown here. You can either win $499, because again, you win 500, but you had to pay $1. So that's a profit of $499, and that probability was 0.001. And then you could lose. And if you lose, you just lose $1. And that probability is 0.999. So we want to find the expected value. So again, there are two ways to do this. One way is to multiply the x's times the p of x, and we get 0.499 and negative 0.999. So then when we add the x's times the p of x's, we get negative 0.5. So the expected value is actually a loss. The other way to do this is with a calculator. And if we go to Stat and go to Edit, I've entered my x's in L1 and my p of x's in L2. You can see those here. And then to define the expected value, we find the mean. So we go to Stat, arrow to Calc, choose var stats. Make sure for list you have L1 and frequency list you have L2, and calculate. And you can see negative 0.5 is my expected value, or the mean of the random variable. But at any rate, you would expect a loss here. Here is another example. In the game of craps, 2 dice are rolled and people bet on the outcome. For example, you can bet $1 that the dice will total 7, and if you win, your profit is 4. What is your expected value? So pause the video and try this one either by the calculator or by hand, or if you want to be really in the know, do it both ways and then come back and check your answer. Okay, here it is by hand. We multiplied. I left them as fractions. I did not reduce them. It made it easier to add. Multiplied across and then add them together. You get negative 6 over 36, which is the same as negative 1/6, or negative 0.166 repeating, which rounds to 0.1667 negative. So you could expect a loss at this game. The other way to do it is with the calculator. So if I go to Stat, I've put my numbers in L3 and L4. Stat, Calc, choose var stats. For my list, I put in L3 and L4 instead of L1 and L2 because I changed where my data was, and go to calculate. You can see at the top you get negative 0.1666 repeating, as we got here. So there you go. Expected loss. All right, let's look at this one. This one is a little bit of advanced as far as when you're thinking about it, because here, notice that the probability distribution is not made. So let's read the scenario. Example 5, carnival game. Consider the following game. You flip a fair coin. If you get heads on the flip, you win $200, and the game is over. If you get tails on the flip, you get to flip the coin a second time. If you get heads on the second flip, you win $40 and the game is over. If you get tails on the second flip, you win nothing and the game is over. So there are 3 scenarios First scenario is you win $200. The second scenario is you win $40, and the third scenario is you don't win anything. So let's create a sample space. The first thing that could happen is you could flip a heads or a tails. Okay, so think about this. What's the probability of flipping heads? That would be 1 out of 2, right? So let's remember that the probability of heads is 1/2. The probability of a tails is also 1/2. However, if you flip tails, you get to go again. So if you flip tails, you could flip heads and win $40, or flip tails and lose your money. Now, what's the probability of flipping a tails and then a heads? You'd find the probability of tails, then the probability of heads, and multiply together, and you get 1/4. So, real quick, let's write what we know so far. So you could flip heads, and that probability was 1/2, or 0.5. Or you could flip tails, and then flip again and get heads, and that probability is 1/4, or 0.25. Or you could flip a tails and a tails, which is going to look a lot like this one. The probability of a tails is 1/2. Probability of a second tails is 1/2. Multiply them together, that is also 1/4. Now, for these, I need to put some numerical values in for my random variables. So let's recall, if you flip heads on the first toss, you win $200, and the game is over. If you flip tails on the first one, you get to flip again, and if you flip heads on the second, it is a $40 win. And then if you flip tails and tails, it is not a win at all. So what is the expected value of this game? Now I'm going to go, I don't know if anyone will find this easier, but you could also, instead of putting these in as fractions, you can put these in as decimals as well. So if we were to multiply each one of these, you would multiply 200 times 1/2, you'd multiply 40 times 1/4, and you'd multiply 0 times 1/4. That would be multiplying all your x's times your p of x's. And let's do a different color. You get 100, you get 10, and you get 0. So when we add these together, you get $110. So what's the expected value of this game? It is 110. I just wanted to pull the calculator up and show you. Go back to that slide. All right, calculator. If we go to stat, enter. If we go over to L5, I'm going to put in 200, and then 40, and then 0, and then L6. You can put these in L1 and L2. I'm going to put in 1/2, 1/4, and 1/4, and then I'm going to go to stat calc var stats L5 L5, and then L6, calculate, and we get 110, just like we got here by hand. So it's up to you, whichever one you want to do by hand or with the calculator. Now look at this next question. What's the probability that you win at most 40? So you could win 40, or you could win nothing. That's at most 40. That means no more than 40. So what's the probability of winning 40 or 0? So you're just going to find the probability that you win 40, which is 0.25, and the probability that you win nothing, which is also 0.25, and add them together. That's 0.5. So the probability that you win at most $40 is 0.5.